This is the laziest part in a car, and the one with the highest instantaneous power consumption. It only works for 3 seconds each time, and its annual working time is less than an hour. But once it starts, the whole car has to listen to it. It is the starter motor. There is a small gear in front of the starter motor, which bites with the engine flywheel when starting, which directly rotates the crankshaft. The engine is forcibly pulled from a static state, and the thickest cable you see on the car now is directly connected from the battery to the starter motor, because at the moment of starting, the current can easily reach hundreds of amps. If such a large current is directly pulled to the cab, the ignition switch would be as big as a fist, and super thick cables are required, which is dangerous and impractical. So, engineers simply use small current to control large current. And this core component is the solenoid valve. The solenoid valve is essentially an electromagnet with a high power switch. When you turn the key, the ignition switch itself only outputs a small current, which is too small to drive the starter motor, but it's enough to energize the solenoid valve. Once the solenoid valve is energized, the internal coil immediately generates a magnetic field, which attracts the plunger inside. The plunger rushes forward. It will press a high power contact inside the solenoid valve, which is directly connected to 2 thick copper terminals. One end is the battery, and the other is the starter motor. This moment, the large current flows into the motor. The starter motor starts to rotate at full power. The click you hear when you turn the key is actually the sound of the plunger hitting the end. More importantly, the plunger doesn't just press the switch, but also through a wave plug, pushes the small gear at the front of the starter motor, pushing against the engine flywheel. And notice that the sequence is to engage first and then power on. The small gear doesn't rotate either. Is not hard to engage. The teeth at its front are inclined, and there is a spiral groove on the shaft. When the pinion slides forward, the spiral groove will make it rotate slowly as it moves forward. Just like screwing a screw, it's easier to align with the teeth of the flywheel. The purpose of this is to prevent gear engagement. When the pinion successfully bites the flywheel, the starter motor starts to rotate. At this time you will find that the difference in size between the pinion and the flywheel. Usually the gear ratio between the pinion and the flywheel is about 15 to 21. This step can already convert the speed to a larger torque, but it's not enough, because you are facing a cold machine. The cylinder is full of high compressed air, and the piston is hard to move. This gear alone is a bit difficult to reduce speed. So in the starter motor, there is also a planetary gear reduction mechanism. Planetary gears are very suitable for this kind of small space, but require a large reduction ratio. In the starter motor, the outer ring gear is fixed, the central sun gear is used as the input, and the planet carrier is the output. With this set, can give you a reduction ratio of about 7 to 1. The final effect is that the motor spins rapidly inside. After 2 stages of deceleration, outputted to the flywheel is already a low-speed, high-torque output. This force is truly qualified to pull the engine into working state. After the engine is successfully started, the situation is completely reversed. This time, the speed of the flywheel will instantly exceed the starter itself. If the pinion still bites the flywheel tightly, the flywheel will drag the motor to accelerate wildly, and the motor will be damaged in minutes. So there is a one-way clutch in the starter. The one-way clutch has a set of rollers inside. When the motor rotates with the pinion, the rollers are clamped. The power is normally transmitted. Once the engine speed, the rollers will be released immediately. Even if the flywheel rotates faster, it won't drag the motor backwards. The starter motor will only rotate idly. It won't be forced to overspeed. Therefore, although the starter motor is the laziest part in a car, behind it is a set of electromagnetic control and multi-stage reduction, plus mechanical protection. A highly coordinated and precise system.